All right, so announcements. There's a couple of them. Let me just first start with, even before talking about the exam, I'll get to this. But for those of you guys who might have come in a little bit late, check your student email for an email from me. Well, check your student email. I sent you the Zoom link and the documents for today. Also send the link for the review from Friday. And what else did I send you guys? The documents from Friday. Canvas is down. Everyone say aw.
No.
Everybody say yay. No? Yeah, StatCrunch is still working. So Zoom, Desmos, StatCrunch, and Gradescope are still working. You guys don't seem as excited as I am about that. Sigh. All right, exam two. As of now, it's still on for Wednesday.
We get an hour more though.
Yeah, if StatCrunch, not if StatCrunch, if Canvas slash Pearson, or either one really, is still down for a significant amount of time, is still down for a significant amount of time today, asterisk.
But what does that mean? That's
The asterisk we'll get there. All right. I will postpone the exam to Monday. Don't thank me, thank the hackers. All right, so
No, he just put the fine line though. Don't get so excited.
No, we gotta come to like an agreement on that.
no, this is a dictatorship.
No, no, no.
What he say? Exactly.
What sound does a waterfall make? All right. I will like basically. I'm not gonna give a time because then you guys are gonna be watching the time. You're gonna be like, it's 6:01, and you said if it's found by 6, but realistically, it's probably gonna be down for a while.
Yeah, but we still need to start the homework and we still have to study for the exam. I think that would be great.
So for example, if it's up by 250,
No.
we're not gonna extend the exam.
If it's not up by 250?
What about 240?
Then
250.
I said, for example.
Oh, God.
Now, if it's down by like 11:58, I'll think about it. Realistically, though, it's probably not going to be up. So I don't want to tell you guys like it's going to be changed to Monday, because it might not be. But yeah, prepare for expect the best, but prepare for the worst. In other words, prepare for it to be on Wednesday. Or no, wait, yeah. But yeah, so just that's all I'm gonna say for now. I know you guys want me to say it's on Monday. I'm not going to right now. When a significant amount of time passes,
That's what I'm telling you. Wait till.
I will have an answer for you guys at the very least by the end of the night. By the end of today. Homework will be extended. Yeah, give me 1 second. All right, homework will be extended for sure. That's a good question. Honestly, it sort of depends on how long Pearson is also down. Also, I have to keep in mind that different people have different schedules. So, for example, some people were expecting to do the homework today, but they might be working later on. Um, until at least Monday. So for those of you guys who are gonna do that's why at least Monday. Yeah, so if it's still down, let's say until like Friday or something, I'm gonna have to extend it quite a bit. Yeah. I'm sorry, guys.
The hacker's trying to.
All right, today is Monday, and we're going to do chapter 8, not chapter 8, activity 1, chapter 8, section 1. Chapter 8.1. And most likely we'll do 4.4 as well, if we have the time for that. Beyond that, we also there was something else. Oh yeah. Log into Desmos, or not log in, but get into Desmos. No, it's not. You can get into it through desmos.com. You guys are in the Zoom, hopefully. Also get into StatCrunch. StatCrunch is still working. So you can go to statcrunch.com. If you forgot your password, figure it out / reset now. And I guess, oh my gosh, I have to do this. I'll give you guys time. I 8.1, yes.
If it was on the homework, it's probably on the exam.
All of 8.1, but honestly, you guys learned pretty much everything in 8.1 already. Yeah. Yes.
Not long.
What?
Okay.
No, I didn't.
Chop, chop.
Okay, so let's kind of just begin. I don't know.
They don't care about the calculator, they don't care about StatCrunch, they're not gonna find your.
Well, it's because the hackers were like, it would be really messed up to take away StatCrunch from these students because they love it. So yeah. So sign in and register here. Go to statcrunch.com, sign in or register. Put in your username, which is probably your email. And your password. If you forgot your username or password, hit forgot username or password and figure it out. Just FYI, not all of you guys signed up through your email. Some of you guys signed up through not all of you guys signed up through your student email. Some of you guys signed up through your personal email. So if you did that, you'll have to look there. Yes, question.
Sorry.
8.1. 8.2 is not going to be on the exam. All right, wait, let me log into Stack. Well, I'll log into StatCrunch right now. Okay, so just to kind of go over again, the idea here is in chapter 8 section, or in chapter 8, really, we're talking about samples and how samples work. So for this example right here, like we had the chapter, let me just read the example on page 1. Women aged 18 to 24, systolic blood pressure in millimeters of mercury, had a mean of 114.8 and a standard deviation of 13.1. So if I actually looked at like the again, the idea here, I'm looking for the probability that a randomly selected woman in that age bracket has a blood pressure greater than 110. So X is the blood pressure of a randomly selected woman. And where are we randomly selecting from? What population are we randomly selecting from? All women who are aged 18 to 24. That's the population. I'm randomly selecting one individual. And so kind of what we to explain the distribution a little bit more, like what these distributions are, they're telling you the probability if you get like a randomly selected, person or individual in this group from this population, what's the probability, for example, that in this case the blood pressure is greater than 110? So keep in mind, like if we actually sampled everybody, we'd have a bunch of samples. This would be like an X value, or this one. We can call this person's blood pressure X1. Then if we randomly selected another woman in this age bracket, their blood pressure would be X2, then X3. You don't have to do the green part. But my point is every single individual has a different blood pressure. Some of them are going to be greater than 110. Some of them are going to be less than 110 in terms of their blood pressure. So I can get a bunch of different randomly selected women in this category, and they'll all have different blood pressures. How many of them have a blood pressure of 110 or more? 64% of them. Or the proportion would be 64. 0.6430. So in this example right here, we were looking at the probability that a randomly selected woman has a blood pressure greater than 110. Okay. Now, in the second example, the difference here is we're looking at the probability that the mean of a sample is greater than 110. Page 1 of the chapter 8 notes. Oh, yeah, that reminds me. You sit somewhere on yes, since you have the laptop, somewhere on the north side. Figure it out. Then you have a laptop as well. So if you can sit over there on the other side. Thank you. Awesome. Okay, so what's going on in this one? Now we have a population. It's still the same population, but what we're sampling from the population is not single individuals. We're sampling samples. So I'll get a sample. And this sample size, in this case, is 40. What is the mean of a sample? X bar. Sample mean is X bar. Okay, so in this case, I randomly selected 40 women and I found the probability their blood pressure is greater than 110. Or actually, let me just back up. I got a sample of 40 women and I measured all their blood pressures, and then I got the average of those 40 blood pressures. Is this the only sample I could get? No, I can get a lot of samples. So for example, I can get another sample of 40 women in this age group, and I would get a different sample mean. Maybe their average blood pressure is 108, whereas for this group, it was 111. And then I can get another sample. And that blood pressure might be 130. And so every single sample has a different sample, whatchamacallit, has a different mean, has a different average. How many, if I got a bunch of samples, how many of them would have a blood pressure greater than or equal to 110? About 99% of them. So if I got a bunch of samples, I could expect about 99% of them to have a sample mean above 110. That's what we're finding, and that's what this distribution is telling you. That's what the sampling distribution of X bar is. If I sample a bunch of samples, how does X bar work? How likely is it to be above 110%? It's about a 99% chance. So that's what this is actually saying. Okay, so that's also why X bar works differently, because we're not just talking about a single individual. So the sampling distribution of the sample mean X bar, it's going to be this shape. It's going to be normal if if either your sample size is more than 30 or the original population was normal. Yes.
So basically, this bottom part, one, was still connected to the above, right? For the 8.1 example was connected to copy 7 example.
Yes, and bless you. I wouldn't
I think he's very confused on like, how to like properly input it into. Does that make sense?
yeah, so we'll get back to that in a bit. Yeah. I see what you're saying. Okay, yeah, we'll get back to that in a bit. But the distribution is going to be approximately normal, and then the mean is going to be equal to the population mean. And it's going to be the standard deviation of the sampling distribution of, sorry, the standard deviation of the sampling distribution of the sample mean. Yes, I know that's a lot of words, but the quote unquote new standard deviation equals the old standard deviation divided by the square root of n. Okay. So I think the question is like, how do you know when to do what, basically, or what to do? Okay.
How to properly, how to know how to, like whenever you're gonna be put where.
Yeah. So reading the chapter 7 example, again, keep in mind this was just normal distribution, fairly straightforward. We read it, they told us that the distribution was normal. They said find the probability that a randomly selected woman in that age bracket has a blood pressure greater than 110. Well, just from there, you just kind of set it up the same way you would do in StatCrunch. Here's the mean, here's the standard deviation, here's the probability I want. Now, what's different about the second question is what you're measuring. I'm not measuring the probability, or I'm not getting the probability for a single individual. And I'm not actually measuring, I'm not keeping track of any single individual. I care about the sample mean. If I get a sample of 40 women, what can I expect from the mean of that sample? And you have to read that from the question, which is, I know that's a little bit, there's not like a, yeah, there's not like a, just like, oh, just plug this in. It's sort of you read it and you kind of understand what's going on. If 40 women in the age bracket are randomly selected, find the probability their mean systolic blood pressure is greater than 110. So you're finding the probability of sample mean. Because again, those 40 women are a sample. So find the probability the mean of that sample, aka a sample mean, is greater than 110. If you're ever dealing with a sample mean, we know this. Sampling distribution will be normal if one of these two things is true, and that's the mean and standard deviation. So if they're asking for probability related to a sample mean, that's when you're gonna, really the main thing you're actually changing really is just the standard deviation. When you input it into StatCrunch, I mean. Because the mean is gonna stay the same. The standard deviation is going to decrease.
We go through like one of those, like each one of those, how to put it in that kind.
Sure, this is actually exactly the same one on page 5. Yeah, it's literally the exact same question. All right, so this is literally the exact same question that was on the bottom of the first page. Women aged 18 to 24, their blood pressure has a mean of 114.8 and a standard deviation of 13.1. So I know X is, actually, do I know X is normal? Sorry, actually, let me define what X is. X is blood pressures. Blood pressures of women age 18 to 24. Do we know if, reading this question, do we know if X is normal or not? No. We do know the mean is 114.8 and standard deviation is 13.1. Yeah, they didn't tell us it's normal here. So this is why we have to be careful. Okay. Now let's read the question and kind of see what's going on. If 40 women in that age bracket are randomly selected, find the probability their mean systolic blood pressure is greater than 110. Okay, so X is blood pressure of a randomly selected woman. Maybe I should actually write. Sorry, I know some of you guys already wrote that. Okay, so X, if we're looking at a randomly selected woman, that would be the blood pressure. We would have represented it as X. Are they asking for the probability that a single woman's blood pressure is greater than that?
No, I think it's.
Yeah, so again, if you read it, if 40 women are randomly selected, find the probability their mean. Find the probability the mean of the 40 women is greater than 110. So this is not a single woman. This is not the blood pressure of a randomly selected woman. This is the sample mean. So this is X bar. Yes. Yeah, exactly. We wouldn't be doing, we just do, it would just be chapter 7. Oh. Yeah. Yeah, so which are we finding? The probability that X is greater than 110 or the probability that X bar is greater than 110? Yeah, because we're finding the probability that the mean of the 40 randomly selected women is greater than 110. So if it was the first one, that would be chapter 7.
So basically the bar on top of the X basically just means greater than?
No, X bar means sample mean.
So what's the difference between the other one? Sorry.
Which one and which one?
X. The one next to it, or,
This one?
the one at the.
She's talking about which are we finding them?
Like why,
Yeah,
how do
she's
we,
talking about that.
Oh,
we notify that?
so what is X? Of? Are we looking for the probability that a randomly selected woman has a blood pressure greater than 110?
No, it's 40.
Yeah.
How would we get?
Okay, so we also have to figure out if it's normal or not. So we have to check two things, and either one can be true. If one of them is true, then we're good. To use the theory we've developed about normal distributions, we can only get away with using a normal distribution if we answer yes to one of the following. Is the original variable where blood pressure is normally distributed? No, it doesn't say anything about them being normally distributed. Not in this example. Is your sample size more than 30? Yes, we have 40 women in our sample. So our sample size is greater, yeah, it's 40. So technically this is approximately normal. I kind of, in this class, honestly, in the classroom, you don't have to worry about that too much. Technically this, if you what it's actually saying is a normal distribution is a good estimate for the sampling distribution of this, but it's not perfect. Question?
If it's not normal, what would we do?
In this class, nothing. In the real world, you'd bootstrap it. So you'd basically get the data you have, you'd simulate it a ton of times until you get something, some sort of shape.
and figure it out from there.
Yes.
Sorry, but I don't know why I'm finding this so hard to like properly understand, but how did we figure out it's like approximately normal?
That's basically, to make a very long story short, if your sample size is more than 30, then the sampling distribution of X bar is approximately normal. I mean, that could be a long, yeah. But pretty much when you have a big sample size, things start looking normal. And that's just real in the real world, which is kind of weird. Okay, so I want the probability that X bar is approximately normal. So let's figure out how X sampling distribution of X bar works. We know it's normal. All right, the sampling distribution of X bar, how can we get the mean of that sampling distribution? Yeah, it's the same as the population mean, which, just to go back up, is 114.8. And just to make this even maybe even more clear, this is the mean of the sampling distribution of X bar is 114.8. Remember, those subscripts are not like a new concept. They're just clarifying what we're getting the mean of, because we're working with multiple things. So it's just telling you we're getting the mean of the sampling distribution of X bar. So the mean of that is 114.8. What about the standard deviation of that? That's for X. What about for the sampling distribution of X bar? Divided by the square root of 40. All right, and if you want to round that to 6 decimal places, that comes out to, I don't know. Yeah, 2.071292.
Wait, 40.
Square root of 40. Sure.
So when to get a new standard deviation, it's only when
We're
we have X bar. Or like
when we're trying to find a probability related to the sample mean. Yes.
when we're trying to find the probability related to the
If we're dealing with the sample mean, then yes, you use the standard. That's the standard. Yes. Woo. Okay, you guys. Yes. Which kind of is given away on the formula card. Why'd you say about the formula card?
No.
I know. Stop going to other websites.
I wasn't, and I still was on the thing, so I was following the thing. And you're talking about before.
Yeah. Okay, so mean and standard deviation of sampling distribution of X bar, these are the formulas. So you notice the mean isn't touched, it's not altered. The standard deviation, now you do alter the standard deviation. Now, if you're dealing with this, if you're dealing with p hat, which we'll do later, these are the formulas. Beautiful.
What's the second? You know,
If it's not the sample mean, then you just use mu and sigma like normal. You don't do anything to the mean or standard deviation. Yeah. Yeah. Okay, so now that we have that, the mean is 114.8, so 110 is probably about right here. This is X bar is greater than 110. Then you shade above, that's the probability that X bar is greater than 110. And then you can do it in StatCrunch. Couple things I'll point out is this part right here. Realistically, you probably won't actually write this part. Yes.
So also like the thing that I wanna like specify for the graph, cause I know you want us to work it off of where we input it.
Uh-huh.
For the exam, if let's first say that's how we shaded in, but it's not exactly how we input it into that crunch. Are we gonna get like points deducted or?
What do you mean that's not how you input it into StatCrunch?
It doesn't approximate the percent.
You mean like if 110 actually ended up being right here, for example?
Yeah,
I'm fine with that. Yeah. Now you should know which side of the mean it is. That's important. Okay, so realistically, on an exam or even on an activity, you might not actually end up writing this part out that I like boxed. I'm sort of writing it out for the notes to an extent. And then even this part, some people just kind of skip. Because if you kind of just know, oh, I'm just going to change the standard deviation. Like honestly, your work could really just look like this. Stat calc normal. Mean is 114.8. Standard deviation is 13.1 divided by the square root of 40. And I want the probability that X bar is greater than or equal to 110. The end. And that comes out to, I actually already did it on the other page. 98.98. Oh, shoot. Yeah, so you notice we didn't actually do anything new at all. This is this. Well, we didn't do anything new that we didn't do last class. Okay, questions? You didn't change standard deviation. Oh, I didn't. Is that 13.1. This one right here. It was supposed to be a 13. There we go. It looks more like a 13 now. Okay, and that's pretty much it. Cool. Questions? Anything I can clarify?
what?
Oh.
No, go ahead. There's one
I
more.
want to ask for a date. How do we know?
Like the exact name of it.
Okay, so the question was for part A, is the variable X normally distributed? Actually, technically, we don't know it's no. We don't know. It's not given. It's possible it could be normal. We just don't know. Yeah, you can say I don't know. The reason we don't know is because they literally don't tell us. So we just don't know. Yeah, that's really the only the tool we're using right now is just have they told us? If they do, yes. If not, we don't know. Okay, and then any other questions? Okay, as a reminder in StatCrunch, you actually can write in Where's my password? Is that my password? Yes, cool. You press it. Okay, data stat, what was it again? Yeah, stat calculator normal. Okay, so you can either do it was greater than 110, and then the mean was 114.8. As a decimal, the standard deviation to 6 decimal places is 2.0771292. Oh, 071292. And you hit compute. You can do it that way, or I think I mentioned this. I'm pretty sure I mentioned this last class. You can also write it as 13.1 divided by the square root of 40. So 13.1 SQRT, and then in parentheses put the 40. So 13.1 slash SQRT, 40 in parentheses. That will give you the most accurate answer. Yeah, sure. 13.1 slash, let me just put it on a Word document. No, but I'll tell you on the exam. Yeah, I don't mind if I don't mind telling you. I might actually even just put it on the front page maybe then, in that case. Yeah.
I was just inputting my number and I was putting SQRT and then my number, and I was like, why isn't that?
Like that? Yeah. Yeah, I'm not trying to test you on like StatCrunch notation, I guess. You're welcome. All right, let's do this. Let's take a break, and then when we come back, do the activity. Back at 12:50. How the heck is it already 12:50?
Work on the exam, can we just write that or?
Yes, that's fine. Well, if you're gonna do that, yeah, that's fine, but you can also just put 13.1 over and just use this column sign. It's up to you. Canvas is down.
No, I'm still gonna save them, I'm gonna do the practice test, I'm gonna finish it. I was working on it earlier. I mostly need help with the owners and. That's the one.
That one's fine. I'm here. For office hours, you mean? 4 to 5 in the math lab. But you roll your eyes, I'll be in the math lab. Just go to the math lab. They have computers there.
So.
It makes me feel like it's like.
And this doesn't?
No, I'm used to it.
But over there, it's like.
Yeah, there's no anything.
Yeah, and
You
so
know,
I know I feel like I'm wasting time every time I'm not.
It literally feels like.
I'm like, if I sit here.
So you're gonna be at the math lab?
I feel like I'm gonna make.
Yep.
Okay. I'll bring all my thoughts.
I can't even. So is there possibly?
I literally was.
Okay,
wanting
the
to
first
say
one I'm taking is the
yesterday, I was
next
doing the
like.
homework.
Oh, so
I
that's
got
like,
stuck
yeah,
on,
so
I
the
even
second
wrote it down, I have like 5 pages.
well, I feel like it's.
You didn't ask my instructor?
Yeah, and then I'm like, okay.
I did,
the
but
final
I
one.
literally was going over and over, and I was like, how the
Yeah.
hell?
I didn't see a single ask my
It's gotta be
instructor
like
from you.
where I'm having-
No,
Then
I was
have to care.
at the bottom right on the left.
I've never listened.
That's why I really care.
Basically, on what you were like.
Sometimes like I'm good. But like it's like so loud.
You gotta like type in a message and of course like, okay, so you can press out and it's instruction, and then there's like a message box, you can like.
Would
input
you allow me
something,
to put like weed on my?
I wouldn't put, I'm not gonna put that.
Yeah.
Huh?
I'm not gonna put them on the exam.
No, no, but I'm saying like, cause sometimes like when I read a sentence, I get mixed up, like like confuse them, but I'm saying like, if I were to write it like,
No,
then like I can't.
No.
Yes.
Yeah, you need to know those phrases.
Found out like, it's because like Ken's putting it like, dividing it by 100 instead of 99, that's why.
I see, yeah, so it's gonna give you slightly off.
By the way, what's the necklace say?
Second.
It's an owl.
Aw, alright, cute.
And
Well,
then
it
they're
was
like.
scientific.
Second.
What about it?
Wait.
Why that, why
Or
is
they
it?
are for winter and spring. For winter and spring. They give it to you.
Literally,
I don't know.
I'm so confused because it's literally like going that way is the amount of zeros that I was inputting, but what happened to this?
Going that way is the amount of times you move the decimal.
Yeah, I think.
So stop thinking about the amount of zeros, think about how many times you move the decimal.
I know for this way it's different.
It's still the amount of, either way, it's the amount of times you move the decimal.
Anyways, I went to go see.
If you're paying attention to the zeros though, that's what's screwing you up.
Like the music section here. And you don't even.
I was getting a little confused by the right, the inequality and internal rotation and fraction.
Yeah, well, and it's like you need to take certain classes.
I know it's going
They're like,
down.
they're like, then you have to take that process that.
It did, so it's like submit, I was like, oh,
Like, what has to-
but I was not.
How do you not know you have the first unnecessary?
That was just like,
I think you were just, your brain is fried.
I think that's what it was,
Are you sure you're not thinking about like get more help?
no, I was missing all the three of that.
Yeah, when I more help, I went right now today. Like I first thought.
Oh, this thing is hard.
In the beginning of the semester, when it's like.
Yeah, you have to get more help.
I had like constructing and it was
And then
like.
you have
It was like people.
It says the direction.
I'm telling you though, like the day before, like enrollment. It's time.
Yo, look,
Technology clear.
Yeah. So I have to make an appointment.
Oh, okay.
So my appointment's gonna be Monday and then. I actually need 3 more GE times.
Really?
Yeah.
I just need a bunch of,
I took it the first semester. I took it at.
all my hard classes were pretty good. Wait, what is your, like, one, two, well, not our classes, but like.
Like a.
Same.
My niece and nephew.
Or like, so not this all, math,
When?
You have to go,
Yeah.
I mean, probably.
When?
Probably.
Yeah, like, we are in December.
That's so good.
Why
Why don't you wanna go?
The umbrella has to show up.
You didn't have to be, you have to show up. They would, if you don't show up, they'll probably.
Your uncle.
That's what I realized at some point, like, oh, they actually want me to show up. Like, that's weird.
It was like easy.
Quiere.
And then you're like.
Like she was so annoying. She was like, I was glad that there was no book.
I don't know, cause I'm just thinking like,
Your best was
I don't know.
Uh,
I never cared if anyone showed up to my stuff, so
Oh.
Because everything was like,
I was never like, I hope people would show up.
That's why we have to break those generational, break the generation, yeah, but it's like, like.
Yeah.
It was mostly because I knew they wouldn't be able to show it, because they have to go first, so like, it makes
The school
sense.
said that it's only.
But like,
the
sit
day
down,
after. And instead of the application.
That's the thing though, deep down, I wasn't like, I hope they come. I was just like, oh, they
That
come.
was the year. I think that's so close to a.
Like, what was the scenario? Were you with?
I guess it depends.
I was so close to a party. My boyfriend was into this.
No, were you dancing too? What were you dancing to? You said recital, like what was the scenario where like?
No, like,
Oh, okay.
why
Did
is
you
it
like?
like anything?
Yeah, did you like?
Yeah.
Oh, okay.
Yeah.
So did
What's-
you-
what's the color?
Yeah, I
Christmas
think let's
thing
take
that is so-
there for wrestling.
Oh,
And when I was younger, soccer and basketball.
Let's be a kid.
Oh, yeah.
I know.
I do, oh my gosh,
I have no nostalgia with
Wait, you don't have to do public.
and that's the problem.
I'm happy though. I like this. I'm chill.
Now, right?
You did wrestling in high school?
Well, it depends, because the community stuff is not, well, there's a section of the TV.
I mean,
So I think.
adulthood is way better than childhood.
Well, that's why.
Yeah, they got that. Give me a second.
I guess, yeah.
I said that.
I say that too sometimes, but like, I rather, really, being a kid not having to like, help go, you know?
Even then, I have no desire to go back.
What?
Look, there's already.
Yeah.
I have no nostalgia for college, like, at all.
Once you found that, I was gonna.
College, maybe. Like my
You
twenties,
don't
yeah.
have, I did this. Girl, I did a flag class where I didn't.
You party a lot, you party.
It was,
No.
communication studies, like, I was,
I thought, I learned math, but
I don't know.
I wasn't invited.
It's on or just anyone. No, the class name was like small group discussion. I literally just asking discussion.
I guess.
And then replying, so that's what I did, I was like, how about speaking from the class, like, no,
But
I tried, like, my problem is just like, like, I asked what council becomes like. So I'm like, oh, no, go to class.
But did you think that's crazy? They did, and I went to work the next day and it wouldn't have on, or my manager was like, I had a little computer class. It was really bad. I don't know what. I
Oh, yeah.
don't.
Like, see, I need one of these.
I love.
Yeah, wait, you're.
I love. What do you mean?
I think I might do it first.
Oh, it's for, yeah? Okay.
Yeah, I might do it first.
I already did that.
Yeah, want to go all the way to Belleville?
Yeah, it's a basic government, we do like further,
But
professors.
Well, not really. We took it 44.
I don't know what you said before that, but I'm gonna serious last one.
Oh, well, my thoughts. You said, oh, 6, 7. Trying to like, when they wear the same shirt.
I was actually talking to this with my mom, I think, yeah, my mom yesterday. I'm just like, my students keep saying that,
I haven't
it's
done
like,
one.
and every time they say it, I just think about like, that's what my 11-year-old niece says.
But yeah.
And yet they're still saying it as adults.
It's nice. I think it's fun and control.
Whatever. It's not really anything, it's just like.
It's also right there.
Like,
6, 7.
my kids do that all the time. And then you know, like, the days when you used to laugh of, you know, what's more funny than 24. Like, I'll be like, oh, they want chicken nuggets, and she'll be like, "6." You know, like, not what's
That's not, that's
No, I don't. Dang, everyone came in right on time. All right, so for the chapter 8 activity, show your work indicating any tech functions, draw a normal curve and indicate the areas and raw scores on the curve. Write conclusion sentences when appropriate. Stat students have GPAs that are normally distributed with a mean of 2.7 and a standard deviation of 0.5. So if we call X the GPAs, then X is normal. The distribution of X is normal with a mean of 2.7 and a standard deviation of 0.5. Find the following probabilities. So for every one besides B, you're going to find the tech input, which I'll kind of give it away. These are all normal. So normal with this mean, this standard deviation, this probability. You are also actually before you do that, you're gonna, of course, draw it out. And then you include, say again?
We kind of did this.
Okay, then do the other ones. Finish it up. Either way, yeah, get the probability and then write the conclusion sentence. I explained it in the lecture. We already did this. All right, go. Work. All right, you guys haven't talked to each other much. You guys have just told me things. So turn to your neighbor across the street. 180 degrees. Thank you. And figure out how you guys want to work on it, and then I'll be here.
We're here one minute and then you. And then plus the turn. I'm probably right. Oh. Getting home, the shower, and then not falling asleep. The shower.
Like 3 shots of coffee, and I just like looked at bed and I feel like I closed my eyes.
How did you sleep?
Oh, it's just like- Dude, it's actually, I could drink a whole coffee. Yeah, I love my hair. I love that. I really
I have to work with them every Sunday.
I've been off energy drinks for 2 weeks now. I did have one yesterday, but that was because I was falling asleep before on my lunch. So I was like, I still have to fast for 4 hours.
My favorite.
I watched Dragon.
Okay, I've listened. It's so good. It's Oh, yeah, audio.
No, we made one.
Yeah.
At least one.
Where?
I don't want to understand.
I mean, you're an adult.
Yeah.
Free will.
Let's do your work.
I'm just randomly selected. Okay. Oh, yeah. Oh, wait, no. Now being right. Their probability is the probability. I know we're done. I think I got it back. We're done. You did? A little bit, all that. So the sampling distribution of next door.
Outside. Yeah, the meeting doesn't.
Yeah, that's what we're
Sorry, the meeting doesn't. I get my desk standard. Yeah.
And
Get ready.
it was the probability of the students that's the GPA of 5, 37.5. Yeah.
That's like that.
So we. Where?
Everyone is seeing that.
That's
So I think I'm ready.
Oh, some schools are right.
Over
So now it's a sample, so it's their probably, like you said, the sample.
Oh, don't like, oh, that's on Monday.
Yeah. Oh, sorry.
The placement of the arms.
Yeah.
There we go. So you go right into the one.
Yes.
I feel like you're having to
Right, it's okay. Try to get that. Or that one. You guys, you sure has some.
It's the way it
Or
is.
the extroverts like to make it that one for the.
I've been a harder with an introvert. I just got there with
What
about you tell them what you're getting?
So how does that work?
They go living, you go.
We kind of did it last time, right? So that's where I left off.
Wait,
We have to round it.
Wait, why did I round it? Hold on.
Yeah, why did you guys run?
Wait, I think that's good. No, that's good that you left it like that. I don't know why I rounded it.
Why did you
And it was
run?
601.
Yeah. Just copy the sentence. You can do that. You can probably copy the sentence too. It'll be fine.
Pretty much, the student has to use get the sentence, like the question, you put the answer there.
Girl, we on the clock. Write it down, write it down. Read this out. Here, write it down. I really.
Yes, I'm like with you.
I was like, I smell it, like, I knew.
To be honest, I just,
It's
like,
just
like,
no,
real.
it's not the same thing, like, I understand, like, I can smell it, and people are saying that, like, I don't know why, it's like, oh, I thought you were like, I
I'm like, wait, what?
I mean, like,
What do you mean?
your senses are heightened to stay away from the nuts, so that's why you smell it.
far up there? Wait, are you looking at it?
Yeah, I'm like.
Oh, I didn't know that. Okay. You know, it's-
Yeah, no, so I wouldn't play again.
But.
She was, oh my god, it's got you don't put on my tombstone, she tried to do that.
I know.
So it was actually.
But if I know that goes.
Oh,
Yeah, no.
But I
It's
know.
actually not bad. But I'm also like,
I feel like
I like how we all have long years, you know, right? And then like, after that, I should go like.
Fourth thing, you just came to center meeting.
So now I'm like, I got experience where, and then like.
Yeah, that's it. Just came to center meeting.
That's
That's the only difference from the stock.
like flour tortilla.
It's made around it.
Oh, yeah.
It's like around it.
Yeah, okay.
Oh,
And strawberries, raspberries.
I'll start.
I'm like, how are you?
Yeah, like.
I know.
Okay, like,
What do you need?
All right, good job, Southside.
Trying to say.
See myself not being.
I'm just saying, Southside. I'm happy about you guys, Southside. You guys are on task. You guys
Just
did work. Good job, Southside. That's all I'm saying.
It's shade, he's throwing shade at us.
Yeah, you just might have to put it.
Oh, so they get the same one?
What?
Yeah, we just gotta probably.
It's 0.945.
Good.
All right.
Oh,
Yeah.
That's all. You know what? I'm just. Me, right?
Oh, no, that's 1.5.
No, this one.
Oh, yeah,
1.5.
I do.
No, it's just me, I thought.
Yeah, I got that comment.
Say I
You're not changing.
Oh, yeah, I can go down there. Everything was good, everything was good. He immediately gave us the answer back. And it was like, okay, the part might take 10 minutes.
Now, you
As
still
long
party.
as I wrote this down, he was happy. What if your guys got?
Are you taking her out?
I don't think so. Hey, got it. I mean, like, it was a little happy, but I don't think I.
Oh, really?
Yeah, I'm just definitely happy.
When you just.
Oh, yeah, I wrote this part.
You're gonna have the energy.
Yeah,
You're just
okay.
like, how do you feel? Just like, just like, you're the person. Because then they're gonna be.
Yeah.
Why did I do that? Because I'm understanding less.
So is it the same part? Like.
Oh, so you were kind of sort of like. You're not used to this.
That's so funny.
Four? No, 45.
I wear the.
Why would I? You're in like.
I thought you'd be.
All right, north side and south side. Good job, north side and south side. Your hands? That is fine.
They're like this very.
Yeah. You do get back to that. But like, the only thing that is that, like, that thing.
Yeah.
What it starts to, I'm not privileged to be guy. No. Families do like it.
Now, how do you get this?
All right, I think these are the solutions to the activity. You guys want to check it out? Over there.
I was like.
Good job staying quiet, south side.
Jackson, because right now, nothing here. Yeah. What's on the board right here, the answer to B? Yeah. Yeah, the answer to B, right here, right here. It's the right. The opposite. It's okay. The opposite. Yeah, it's. Oh, that's. Yeah.
Lopez, I think, wants 16. Oh, yeah.
Say again? Yes.
Yeah, that's.
If you actually have the exact answer.
You're fine, good.
You really hate that. I thought we would.
Yeah, I was so. Oh, we got to pay, but next bar.
On the exam, are you gonna give us the stats? It is right. Cause that's why I'm. It's right there.
Yeah, just run for it. Yeah, so the probability is extremely low. If you actually look at it, 3.2 is like. Yeah, so if you run it for it, that's now, obviously, it's not exactly zero, round or the. So out of every 10,000 trials, you would expect 6 sections. Or if you had 10,000 trials.
I'll do it.
Oh, yeah. Yeah, I'm gonna the same.
Yeah.
I guess you guys said yes, and you're like.
I think. And then we try to get our verification. That's for example. Let me do it on
The standard.
Oh,
Where'd you put it?
I put the wrong,
And if you do it, like, this is
No,
not
not
like
accessible.
right?
You don't have to.
No.
We'll put it on, I know it's just-
So it's like.
I mean, the drawing's gonna kind of look like that. If you guys can see this. 95% of all values are less than. Yeah, but this is still what it.
You know, we didn't know what the value was and we just input it as like, the answer already. So just give us the probability of it.
Oh,
Yeah.
with the opposite instead of.
Yeah, yeah.
Yeah.
Yeah, so the 95.95.
Yeah, because I told you, yeah.
Also, yes.
I remember this correctly, so the standard descent.
Oh, you got it?
Yeah. So let's say it's, if a single, so it's from, like when it comes to. If we don't something. And the standard deviation, we can't do the.
Mid-city questions, queries, concerns, anything?
No. Yeah.
What's the first thing you hear? Yes.
Yeah, the graph, okay. Oh, yeah, and then.
Just gonna start with the underline.
Oh, no, this is
Like the first.
zero. Yeah.
How far you want away, okay? Around the other way. Oh, no, that's on the other side, okay.
What side is this there?
And
Side.
could be rounded to 4 decimal places, so that's fine, I guess. It's fine. I think that's how you do it for a living. Oh, yeah, I think it's like you are. It would be this one.
Wrap up soon, a couple more minutes.
Yeah, yeah, so you would input it 0.5. There's a lot. X.
I got so much stuff.
16, and this should. But you don't have to directly calculate it, but it's just.
You can see these, right? Like, it's because the graph is like, literally like, where do you want me to fix it? I can actually see that. Alright. Now the graph isn't right, but it's not. I think the second one.
Put it too far to the edge.
You know that's not 0.95, here's 2.7. And 2.7 is here on the line, so 1.95. Yeah, but that's not on the number line.
What I did was either put 95%, peak of probability.
Yeah, so it'd be more like this. 95 is not on the number line.
Julian.
Yeah, 95 is not here.
Oh.
We don't know what's, well, you just found out what's there. What's there is 2.956.
That's a lot. There's a 90.
All right, couple more minutes, then we're gonna wrap up.
That's very, for this one, I was thinking, you put it the same way, but I read it better now. Yeah. No, yes, it is. No. It should have been over there.
Oh, so I got you right, I just wanted to second, so I did it right. So that stays the same, that stays where it is, that's.
That's what happened.
But 0.95.
Wait, so the probability is 95, that's what it equals out to. So we're trying to find this part. Oh, okay. We did that before.
Wait, can't you input it? You have to input everything else. And
Yeah.
You have to be 0.95.
Oh.
I didn't say wrong.
Yeah. Yeah, it is.
And then for this one, we're supposed to round 4, that's not the. Yeah.
Maybe, yeah.
Actually, come from.
I don't know.
Huh?
You're getting average. I think we're gonna have to use that.
Oh, no, that's right. It's all down. No, my plans are foiled. No? You can do what people have done for thousands of years before phones were invented. Interact with people. Interact with people and be healthy social individuals. All right, so let's wrap it up. Let's go ahead. Are there any questions? Anything you guys want to ask about? Double check.
Yes.
Go ahead. For part D.
About sensing what would be ideal for you?
What would be ideal for me? Well, basically, conclusion sentence about part D. I probably would say, honestly, my conclusion. Oh, E. I would just do this. Whatever GPA you got, just replace that right there. If 16 students are randomly selected, there's 95% probability that their mean GPA is below blank points. And that's it. Oops. Hold on. Sorry. Where is it? Where the heck did Desmos or did? Hold on. Sorry, hold on. Let me do this one more time.
Oh.
I guess it's not showing. That's so weird. Okay, anything else? Nothing?
This one was asked.
All right, in that case, please submit and also pick up the chapter 4.4 notes.
Still working on it. Oh. Here.
Oh, is this yours? Oh, sorry. All right, so for 4.0, sorry, 4.0, for 4.4, we are going to, oh, thank you. We are going to be using, not StatCrunch, we are going to be using Desmos. So I'll give you guys a couple minutes again to finish up, and then we will start 4.4.
We have to leave the class.
Say again?
We have to leave the class.
You guys have until the end of the day to submit.
Oh, yeah.
Yeah, just make sure you. Yes, 4.4 is going to be on the exam. Yes, I said 4.4 is going to be on the exam. I've been said it. I'm just kidding. I'm just kidding. I'm sorry.
Does that just somehow?
I'm just kidding.
And then I'm like, I don't got my notebook. Grab my folder. Things are gonna disappear in Delilah's. I just need to wait for it.
Only 7 more chapters to go. Oh wait, chapter 4 also. 8 more chapters, I'm sorry. All right, have you guys submitted? Almost. All right, so I'm gonna start 4-4 now. Contingency tables and association. So just real quickly, obviously as you guys noticed, we didn't finish chapter 8 notes yet. Basically, chapter 8.2 is not going to be on the exam. So to remind you, yeah, that's what I'm gonna do right now. Usually I would be like it's on Canvas, but Canvas is not up. Yeah. Is it?
No. No, don't. I did it actually 2 minutes ago, it's not up. We still need to, okay. Yeah, exactly. Like an hour.
I can't with you guys today. Okay, so the exam will cover 4-4, chapter 5, chapter 6, chapter 7, and chapter 8, section 1. So no 8.2 on this exam.
No, it's got to be out right now.
What sound does the waterfall make? What sound does a waterfall make? Thank you. Okay, so again, like I said, I just put it down. The exam is going to cover 4-4, chapter 5, chapter 6, chapter 7, and 8.1. Chapter 8.2 is not going to be on this exam. We may cover it today if we have time, which I think we actually will have time. But that's also why I want to get 4-4 out the way, because this is going to be the new material. For this, you do not need StatCrunch, you just need Desmos. All right, have you seen a table, any type of table that looks kind of like this type of table? Yeah, so this table is called a two-way table or a contingency table. The following table represents the employment status and level of education for all U.S. residents 25 years or older in November 2014. The totals were added to make it easier. Sometimes you have to add them yourself. So the way I read this table, again, and this is why having it labeled is so nice, because the rows are organized by employment status. Either you're employed, you're unemployed, or you are not in the labor force. And then level of education are the columns. This is the highest level of education. So those that did not finish high school, that's the highest. Then high school graduate, then some college, then bachelor's degree or higher. Let me mute this real quick. Yeah, let me mute the Zoom really quick. Exactly. Anyways, back to being recorded. Okay, so anyways, you guys are at least here actually, some college.
That's crazy.
And if you get a bachelor's, you will have a bachelor's or higher. You will be in that select group. Woo! All right, so if I want to find the amount of people with some whose level of education is some college, Who are unemployed, where do I find the frequency for that? Yeah, I basically find where where that row and that column meet up. Let's say I want to find the amount of people who are unemployed, who their highest level of education is high school graduate. Yeah, I just figure out where unemployed and high school meet up. So that's really all these tables are. There's nothing really more to it. North side. How did we get, or how could you compute this number? How could you find if this was not here? North side.
You add all of the numbers of the people who didn't, wait, no. All the numbers that did not finish high school column, and
Yes.
then that will give you the total.
Yep. Exactly. If you add these three together, you get the total right here of 24,395. If you wanted to find the total amount of people who are employed, you would add these four together.
Does double counting also occur in this table or no? Like it does in the other?
It can, for
Yeah.
sure. Well, if you double count something, then yes, it will occur. If you don't double count something, then it won't. That kind of actually gets us to the total. Yeah. So south side, how do that total of 208,720, how can we compute that total? South side.
Oh, just like add all the totals of the totals, if you will.
So add up,
So on the bottom. Right, Fran.
so add these all up?
It's not top row and bottom row together, like just like top row and so that would get you that, and also like bottom row and so that will get you that.
Yeah, so keep in mind if you added the column, if you added these as well as these, you're double counting everybody. So for example, the person, if anybody who's employed and did not finish high school, they were included here and they were included here. So you just counted 10,179 people twice. And so you said, oh, that's actually 20,358.
In progress.
It's all good. So yeah, either you add the column totals, you add these four values, or you add the row totals, these three. You don't do both of them, because then you're double counting everyone and you'll get double the amount that you're supposed to have. All right, how many adults were surveyed? Yes, exactly. 208,720. Yeah. Also check your email. I sent an email with the link and everything. Yeah. Woo. All right, so another thing real quick. These totals at the margins. Do you see these totals at the margins? These are called marginal frequencies. The reason they're called marginal frequencies is because they're frequencies on the margins. That's literally it. Margins are like the edge of something, basically. So all those totals are also called marginal frequencies. Yeah, so they're frequencies on the margins. That's why they're called marginal frequencies. So if I ask you for the marginal frequencies, don't freak out. It's just fill out the stuff at the end, at the edge of the table, I should say. Okay, so we can get frequency. How many people were employed?
In total?
Yeah, in total, how many people were employed? Is that a lot? Is that a little? Is that most of the group? Yeah. So in other words, we have to get the relative frequencies. Or since they're on the margins, we're going to call them the marginal relative frequencies or relative marginal frequencies. Either way is kind of the same thing. And again, this is why I say understanding what each word means is more important than just memorizing like the definition of each one, because then it could be really overwhelming. Again, margin just means at the edge, and relative frequencies are relative frequencies. So what we're going to do is we're going to get all of these values on the margins. And then we're going to divide by the total of 208,720. So for example, 128,744, I divide by the total amount of people. And that gets me the first relative marginal frequency. The next one, 6,395, divided by 208,720. That gets me the next one. Yeah, 4 or 1, hold on. Probably 4. Yes, relative frequency. Same thing as relative frequency. That's why I've been screaming relative frequency for so long, because it just doesn't go away. Even in real life, it's never going to go away. Every time you see a percentage, that's a relative frequency. Every single percentage you've seen, I would say, is relative frequency.
Round to the nearest what? You said 4.
4 decimal places. Ultimately, you guys aren't turning this in. These are actually notes. So it's kind of up to you how much you want to round, honestly. Yes. Or actually, are we going to finish chapter 8, activity 2 today? Probably not. But you guys will work on it. Okay, go ahead and, oh, and then, yeah, go ahead and find all of these. And then find these as well. The solutions are here. I did have to switch to them. I think there's an easy way to do this in StackCrunch, but I forgot what it is.
This is a Desmond situation.
It's the same thing. Well, we're just. You need to put it in front of it.
Yeah, I forgot how to do it in Desmos, or how to do it in StackCrunch, I mean.
Or that's what basically the app after that. Okay. Or after that. So that would be flat. Oh, he's going based off these? Or does it based on just
It's all relative. We're all relatives. One big fact.
Alright, questions, pretty straightforward. Should I put the answers on?
Yeah.
I don't know if it is really wrong. Because I add them all up, I got it, like,
All right, is this pretty straightforward? Okay, I'm just gonna put up the solutions or the answers.
the after.
Let me know if any of these are wrong.
Yeah, so this time. So this number.
Yeah, cause it's a 3. So
35, 25? Really? Okay, interesting. What does it come out to?
35, that's 35.5.
Yeah, 0.3535.
It's a 3, so it doesn't round.
Yeah, okay, so then the other ones are shoots. I think I only did this one to 208, 720. Like that? Okay. All right, and then the last one is 3285. Okay, so a couple of things. Notice that if you actually added these three up, you don't actually get 1. 0.9999. Yes, because 8 plus 6 is 4, 14 plus 5 is 19. So it's going to end in a 9. That's kind of my cheap way of checking.
Okay, I don't want.
Put those in StatCrunch and what do you get? Or not in StatCrunch. Add those in Desmos and what do you get? You'll get 6168 plus 0.0306 plus 0.3525 end up being 1. Yeah, if I add those three numbers together, they actually add up to 0.9999. So this is sort of an important thing. What sound does waterfall make? Thank you. So keep this in mind. Whenever you're rounding, you're not getting the exact answer. So you're losing some precision. So sometimes this is going to happen where when you add them up, they don't come out to exactly 1. Because again, every time we round, we're losing some precision. We're losing some accuracy. That's okay. Just leave it as it is. Okay. What proportion of adult Americans are employed? Employed. Employed.
0.4.
Yeah. And another way of thinking about it is 61.68%. So about 6 out of every 10 Americans are employed. What proportion of adult Americans have a bachelor's degree or higher? Yep. Or about 33%. So if you guys get a bachelor's degree, you guys are in the basically top third in terms of education. Assuming that these things, well, I'm even higher because I have a master's. Kidding.
32 and what? 32.85. Where did you get 32.85?
32.85%?
Right here.
Wait, do we have to do it that way?
What way?
Like
Doing
work?
no,
Oh,
No, I didn't ask for the percentage technically. Actually, these stats are probably outdated. Let me check. What percentage of Americans have a bachelor's degree or higher? Oh, it's still 39%.
Back in 2025 though.
Although for 25 to 39, 2025, they don't have those numbers out yet.
So what is that?
It's some numbers. It's proportions.
So we did that.
Can you do what? PhD? Sure. What percentage of Americans have a PhD? 2%.
It's been expensive.
1.8% of women and 2.5% of men.
Take all of that.
Well, this is why you guys have to make this equal. Go get your PhDs.
More money.
All right, speaking of conditional distributions, a conditional distribution lists the relative frequency of each category of the response variable, given a specific value of the explanatory variable in the contingency table. So that is the definition of a Thank you. That is the definition of a contingency, conditional distribution. Let's kind of remember what a response and explanatory variable is. A response variable is explained, the value for an explanatory variable should explain or should in some way predict or should in some way be correlated to the value of the response variable. So an easy example of an explanatory versus response. Explanatory should affect, the value of the explanatory should affect Mid-City. Quiet. Let's say your GPA and your study hours. Which one affects which? Yeah, study hours basically would be the explanatory variable, and GPA would be the response variable. So something that's kind of hard to define about explanatory versus response is like any variable can be either one. It's really not talking about what is that variable. It's talking more about what's the relationship between the two variables. So which one kind of comes first, so to speak, is sort of one way of thinking about it. The explanatory basically comes first. I put first in quotes, in air quotes, but that's kind of the way you should think about it. The amount of study hours you do should predict your GPA. Okay, so a conditional distribution lists the relative frequency of each category of the response variable, given a specific value of the explanatory variable in the contingency table. So in this case, we're going to construct a conditional distribution, treating level of education as the explanatory variable and employment status as the response variable. What does that mean? I mean, I'll start off. It's going to be this each cell frequency divided by the marginal frequency of the given value of the explanatory variable. Okay, so level of education and employment status. Which one do you think is the explanatory here? Level of education should predict your employment state, or we're trying to see whether level of education can explain or is correlated with your employment status. And employment status is the response variable. We're trying to see what the relationship is between level of education and your employment status. Are you more likely to be employed if you have higher levels of education? That's what we kind of want to see. So it's going to be the cell frequency divided by the marginal frequency of the given value of the explanatory variable. So here's the explanatory variable. The marginal frequencies were on the bottom for level of education. We're going to get each value from the first table and then divide them by the column total, basically. So remember this table here? I'm gonna get all these values, and I'm gonna divide, or sorry, let me go up more. I'm gonna get all these values, and I'm gonna divide by 24,395. Yeah. Then for high school graduates, I'm gonna get all these values and I'm gonna divide by. Exactly. And so on. So the idea here is, again, you have frequencies, now you're making them relative, but you're making them relative with respect to education. So you're basically seeing, for example, in the second column, how many people who their level, if your highest level of education is high school graduate, what's the probability that you're employed? What's the probability that you're unemployed? What's the probability that you're not in the labor force? And we can compare that for high school graduates to what are the stats for those who did not finish high school.
You rounding to the 4.
Good question. What did I round to?
4.
It looks like I rounded to 3 this time. If you want to round to 4, you can still do that. I won't stop you.
Oh.
He said it's your own paper.
Yeah, but my solutions are in 3. Why 3? Because that's what I chose. All right, so yeah, on the other page, you just copy these numbers and you divide them by the column total for each. Sure, yeah. So I'm copying pretty much what's on the first page. Um, 945, 13,271. And then for each column or for each cell, I'm dividing the cell frequency by the column total, the marginal frequency for that column. So the first column had a total of 24,395. And then the first column for me comes out to 0.417.
So can we add all of them?
Yeah. And then you're gonna notice something, I think for the first one. Yeah, I think that's why I actually rounded to 3 decimal places to make that point.
So round to 3 decimal point?
Sure. All right, go ahead and complete. The contingency tables are easy, they're easy points on the exam. Or sorry, two-way tables. Contingency, conditional tables are, those are a bit harder.
These are conditional tables, the backside, right?
The backside is conditional distribution,
And then
yes.
the front is something.
Yes, two-way or contingency.
You said on the Zoom that the conditional distribution is the
The conditional is not, no. But the contingency table, basically the back page of this is not gonna be on the exam. Or let me maybe rephrase that. You won't have to create. one. No, yeah, it won't be on the exam. It won't be on the.
And I have to create a condition.
A conditional, no. No,
It's
the
not
back
it?
page is not gonna be on the exam. The front page is fair game. I think it's nice to be able to construct and understand it. It's just realistically, I think it's gonna be a headache, I think, on an exam. Where you forget what you're supposed to divide by and all this.
So will it be on the next exam or?
Conditional?
Yeah.
No. No, I'm just letting you know for the conditional. is not coming. It's on the homework. So make sure you do your homework in 30 minutes.
Homework. We can't access it.
I know, that's
That's the joke.
the joke. Answers are up here.
Yeah.
Woo, okay, those were what I got.
Wait,
Wait, what?
for your bachelor, the first one was wrong.
0.722?
Which one?
Yeah, me too.
For the bachelor degree or higher, the first one?
6168?
Yeah, so 0.617. Wait.
Like that?
I got that.
That is-
Woo. Okay, so let's see, bachelor's degree or higher, that's 49,534 divided by 68,564. Four nine five three four. Yeah, so this is an obvious case of why you work with other people. Because someone's gonna check your mistakes. 7224. Maybe you guys mixed up or maybe I mixed up numbers? No. No, that's not bachelor's degree or higher. Yeah, okay, I see. So I think the issue, what sound does waterfall make? Thank you. I think the issue was everyone was going straight to the last column and then kind of doing basically doing the relative frequencies here. But the last column on the conditional is for bachelor's degree or higher. And so it's going to be using this column right here, these numbers here. Okay, so looking at these numbers, what do you notice about the probability you're employed as your level of education increases? Oh wait, this is 722, yeah. As your level of education increases, what do you notice about the probability that you're employed, that an individual is employed?
It increased.
Yep. So the more education you have, the more likely you are to be to have a job, basically. And you're less likely to be unemployed. And you are also less likely to be not in the labor force as well. Also, what did you notice when you added these up?
They all. What? They all add
Do they?
ish.
What do these add up to? What about the next column? Yeah, okay, I think they do add up all to one.
There's 1.001.
No, yeah, 2 plus 4 is 6 plus 5. Yeah, this ends up being 1.001. So again, we lost some precision. When you rounded, you overestimated a bit. And then the last one comes out to 1. Yeah, 2 plus 4 plus 4 is 0, so it's gonna be 1.000. All right, and that information is also in this table right here. All right, so questions or anything? Sure. That's off by quite a bit. Yeah, you want to check that for sure. Yeah, so if you get like 1.01 or 0.999, that's usually normal. If you get something like 1.007, sorry, then you definitely want to check. Or if you get like 0.994, then that's probably not a good sign. Nothing else? All right, if you are done with this, you can put it away. Chapter 4.4. So again, the first page is fair game on the exam. The second page, I mean, the second page technically is fair game, but I'm not going to put it. Unless you guys really want it. The first page is fair game for the exam.
Yeah.
Of this document.
Oh.
The second page, I'm not going to have. Conditional distributions will not be on the exam. But they will be on the homework, which you guys will do eventually when it's up. All right, so this is going to be kind of a weird shift, but we're going to go back to chapter 8 now, since we covered everything that's going to be on the exam. Pick up the chapter 8 activity 2, and then be back in at 2:10.
There you go.
Yeah, so I'll do it right now when I come back.
That makes sense.
Hey, double check, and does this look fine right here? All right.
I don't know if that's the answer or not, but it looks like it makes sense.
And do you have the?
No, I put them away.
Where?
So you can see if everyone else got it. I think they got it.
Oh, yeah. I think I know what you're talking about. Yeah, I believe it. Oh. Maybe give that. I'm in the process. Is this something? No. Is this something that if you can take it out? Yeah. That's like here's the information you did not want to give it. Oh.
I mean, it doesn't too empty. I really got it. Or maybe it's just like, I need a break.
No, no breaks.
Yeah, but, I know I want to be so social. Like.
Hey.
I mean, I think.
This is your break too.
Yeah.
Technically,
Is this not a time basket?
you can ask.
Okay.
It's okay.
Is that why students always make sentences with extra words for no reason?
It's not, it sounds like we're looking at it.
In addition to what was stated above in the previous paragraph. Yeah, please don't do that on my assignments. Clarity, clearness. I hate it. All right, so section 8.2, distribution of the sample proportion. Recall that proportion is denoted by the letter P. If we gather proportion from a sample, we call it P hat. And I don't think I've actually gone over this, so maybe I shouldn't even say recall, because I actually don't think we've discussed this yet. Okay, basically, if you have a population, someone give me a number that could be a proportion. 24, no, can't be a proportion. It could be, or as a decimal, it would give me like a decimal version. Yeah, so it has to be a number, either a fraction where the top is smaller than the bottom, at least in this class. Or in this class, again, proportion is between 0 and 1. So the proportion of you guys who are wearing Nikes might be like 0.37 or something. If the proportion comes from a population, so if I'm looking at all SMC students who are wearing Nikes, the proportion is P. Actually, we did look at P before when we did binomials. So population proportion is P. Sample proportion sample is smaller. It's more exclusive. It's only the cool kids who wear hats. So sample proportion is P hat. If you're talking about a population proportion, we're going to use the letter P. If we take a proportion from a sample, it's P hat. Again, as a reminder, like proportion is going to be the same thing whether you take it from a population or you take it from a sample. It's the amount. It's basically relative frequency. Let me put it that way. Relative frequency is your frequency divided by the total. Proportion is the same thing. So sample proportion P hat, the way that we compute it usually. Actually, yeah, kind of going back to when we were talking about the fraction thing. How do we get a proportion in general? Let's say I want to know the proportion of you guys who are eating cup of noodles right now. How would I get that sample proportion? How would I get that proportion? Same thing as probability. You can eat it. I'm not saying you can't eat it. That wasn't. Yeah, I was just picking a random thing I saw. I'm sorry. I didn't mean anything like by that. All right. But how would I find the proportion of people who are eating cup of noodles? Yeah, so the amount of people, which is X over the total amount. P hat is X over N. So again, if you notice, same thing as relative frequency, same way we got probability. Same way proportion. If you remember a binomial, that's how a binomial, like the P in a binomial, that's how you get it. All right, X is the number of individuals in the sample with a specified characteristic. If you want to know what X and N are, they're right here. X is the number of quote unquote successes. I just want to be kind of clear again. When I say success, it doesn't necessarily mean something good all the time. It just means like whatever you're measuring. So the sample proportion P hat is just the proportion you find from a sample. So again, when I see the phrase sample proportion, the more important word is proportion. It's a proportion that comes from a sample. That's all it is. Population proportion P is just the proportion from a population. Okay. So if I want to know the total amount of, let's say again, I want to know how many people are going to vote in the next election. Why would I get a sample proportion? Why would I only look at 300 people? Yeah, exactly. A lot of the time we can't get we can't analyze the entire population. Because if I want to know how many people are going to vote in the next election, I have to ask everybody. And everybody is not possible because I can't interview millions of people myself. So what we do is we get the sample proportion, and usually the reason we get it is to estimate population proportion. That breaks my heart. I'm just kidding. Okay, this is actually not a crazy idea. Every single survey is a sample report. I shouldn't say every single survey. Almost every single survey is a sample proportion. And so when they say like 47% of people are going to vote in the next election, they don't get a population. They just look at a sample of maybe 1,000 people. So you have real life experience of using sample proportions to estimate population proportion. You do it all the time, and you accept surveys and samples all the time. Okay, important. Sometimes the sample proportion will not be given. So sometimes it's going to be given. Sometimes I'll just tell you 33%. Sometimes it won't. I won't give it to you. If in the case where it's not given to you, you're going to use P hat equals X over N. Which again is just, that's really just restating what I had above. You have to compute it yourself. All right, so let's get our hands on a sample proportion here. The Harris Poll conducted a survey of 1,200 American adults who vacation during the summer. Of those surveyed, 5 indicate that they plan to work while on vacation. That's me all the time. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. So go ahead and do it with your neighbor across the street. I guess maybe this one didn't require that much. All right, so what'd you guys get? And how'd you get 0.46? Yeah, because we want the sample proportion of individuals surveyed who plan to work while on summer vacation. So again, the word sample is just telling you you're getting it from the sample. You're getting the proportion here of individuals surveyed who plan to work while on vacation. So P hat equals 552 over 1,200, which is 46%. Exactly, right? Okay. All right, so how many, if we looked at all American adults, how many plan to work while on vacation? What proportion? No, we don't know. We only know for the sample.
We'd have to know the number of all.
Yeah, so the actual population proportion is unknown. But we got a sample of how many people? 1,200? And the proportion of them who are gonna work is 46%. So again, I want to point this out because I think this sort of trips up people, especially later on. Like we do this all the time. Every single time you do a survey, or almost every single time we look at a survey, it's a sample value. But we expect that P is probably going to be 0.46 or around there. I think that's a pretty good prediction. Am I 100% certain about it? No. But it would probably be a good guess. My best guess for P is probably about 46%. Okay, so 46% of American adults surveyed, not all American adults. Plan to work while on summer vacation. That is my job. I like my job. It's busy, but it's also fun. Better than being in front of a computer all day. Or in like a cubicle all day. Yeah, okay. So yeah, we know that P hat in this case is 0.46. We don't know what P is, and that's fine. Let me ask you guys a question. Let's say I got another sample of 1,200 American adults. And so I got another P hat. Do I know what that P hat's going to be? What the proportion of that second sample is going to be? Who work on summer vacation? So if I get a completely separate set of 1,200 other people, would I know what percentage plan to work while on summer vacation? No, I don't. But if I'm able to figure out, maybe I'll be able to figure out like it's probably going to be over 46%. It's probably going to be over 50%. It might be less than 50%. If I can get the probability for these things, that would be really nice. If I can figure out the distribution for P hat, because again, every single time I get a sample, they're all going to have different proportions. Just like when we did the pineapple on pizza, the proportion for you guys was different than the proportion for my other class. For you guys, how many of you guys like pineapple on pizza? Was like 48%?
Lower, I think.
Let me check. Do you guys know? You guys don't remember when we did that? What day?
I would.
All right, for you guys, I believe it was 48%. For my other class, it was 25%. So yeah, the sample proportions are different. Their sample was 25% like pineapple on pizza. And then yours was 48%. So you guys have almost twice as much taste as them, basically. Okay, so my point is every time I take a different sample, What sound does a waterfall make? All right, every time I take a different sample, there we go. I'm going to get a different proportion. How are those proportions distributed? What is going to be the average of all these proportions? If only I could figure out what the distribution of p hat is. Oh, wait, I can. Yes. Yay. So just like we had a sampling distribution of x bar, we have a sampling distribution of p hat. Exactly. Woo! All right. So for a simple random sample of size n with a population in proportion p, the shape of p hat is going to be approximately normal if n times p times 1 minus p is greater than 10. So ultimately what this means is if n is big enough, because p you can't change. P is just a proportion from the population. So p times 1 minus p is going to be some number, usually going to be pretty small. And then you have to get a big enough sample size to make this left side bigger than 10. So let me show you guys an example kind of in Desmos or in StatCrunch, I'm sorry. Do you guys remember when we talked about left-handed people?
Yeah.
All right, what proportion of the population is left-handed? About 13%. Or at least that was the number back then. Is it still that number? Oh, 10%. It's gone down? Oh, well, we'll still use 13%. All right, so if I only sample 10 people, if I only sample 10 people, does that look like a symmetric normal bell-shaped distribution? No. So the idea again is p, in this case is 0.13 times 1 minus p, and I have to make n big enough so that that thing gets above 10. So in other words, if I make n big enough, it starts looking normal. And so I get something that actually looks like a normal distribution.
I should put this in stack. Where are we getting the 10 from?
Let's put it this way. The formula is n times p times 1 minus p, right? We're not doing really a question. All right, so the formula is n times p times 1 minus p, right? Has to be greater than 10, right? Yes, no? Yes.
Greater than 10 or greater than or equal?
Greater than or equal to. Sorry. Yeah, so let's say we're looking at left-handed people. Either you're left-handed or you're not. Okay, so I want n times p times 1 minus p to be greater than 10. If it's greater than 10, it starts looking normal. Let's see if n equals 10. Is that more than 10? No. So let's do 20 people. Is that more than 10?
No.
40 people. Is that more than 10? 50 people. 80 people. 90 people. Yeah, so if I have 90 people, I can approximate this with a normal distribution. If it's lower, it's probably not going to be accurate. And I mean, I can just show you, like even for 40 people, let's see what the distribution looks like. It looks kind of normal, but it's still right skewed. And so that's not good enough. That was just there. Yeah, you can ignore that. You can put any number. If you do 4,000 people, it looks very normal. Woo. All right, so all of that to say, if you have a big enough value of n that makes n times p times 1 minus p greater than 10, you can approximate what's going on with p hat using a normal distribution. The mean of the distribution of p hat, again, remember that subscript doesn't change the concept. It's just clarifying what we're taking the mean of. The mean of the sampling distribution of p hat, and yes, I know that's a long phrase, the sampling distribution of the sample proportion is p. In other words, if I take a sample, I expect on average, it's gonna come out to the overall average, the population average. If 47% of people are gonna vote in the next election, I expect 47% of my people on average I expect the sample to be about 47% of people voting in that sample. The standard deviation is something. Formula card, save the day. All right, the mean is P, and the standard deviation is square root of P times 1 minus P over N. Isn't that beautiful? Actually, wait, have you guys... I think we've seen this. What was that? It starts with a V and it rhymes with variance of a binomial distribution. Of? I think so. Yeah, because this was a standard deviation of a binomial random variable. If you square it, you get rid of the square root. Yeah. All right, so let's go ahead and let's do an example. Take a breath. All right, according to a study done by Wakefield Research, the proportion of Americans who can order a meal in a foreign language is 0.47. Suppose a random sample of 200 Americans is asked to disclose whether they can order a meal in a foreign language. So a couple things that you can do here. This is something that you're going to want to actually do, because when you get to the other parts of the questions, or at least for me, when I start doing these questions, I don't want to have to keep on reading this every single time, because that's really sort of frustrating and figuring out what is 0.47. I don't want to have to figure out what 0.47 represents here and here and then here and then here and then forget and be like, oh shoot, what was 200? Exactly. So 0.47 is the proportion of the population in this case. Actually, this is kind of weird. Technically it was a sample proportion, but we're assuming that the proportion of all Americans who can order a meal in a foreign language is the same thing. That's what Wakefield Research is saying. And then the sample size is 200. That would be your N, yes. So some students like just circling it and then like doing the arrows to show what each one represents. If that works for you, that's completely fine. Personally, for me, I like just putting them on the side, what N and P are, or what my variables are. In any question, once I get information, I like putting them on the side. N is 200. And the proportion of Americans who can order a meal in a foreign language is 0.47. I like having it there so I don't forget it. Okay. Describe the sampling distribution of p hat, which is the proportion of Americans who can order a meal in a foreign language. Be sure to verify the model requirements. So when I say verify the model, there's a couple of different ways of saying this. Verify the model, show that the central limit theorem works. Essentially, I want to show that this is a normal distribution. Or that it's approximately normal. So I need to show that. What would make the sampling distribution of p hat approximately normal? What would make this approximately normal?
You gotta do it 2 times, what is it? 0.47 times 1 minus 0.47.
And what form?
You gotta see if that's like over 10.
Yep, and what formula are you using?
1 minus b is greater than or equal to 10.
The variance of binomial, because this is binomial. Either you speak a foreign language or you don't.
Show that the variance is more than 10. And how do you do that? You plug in the numbers. Oh no, wait, it is recording. Okay, good. Yeah, you plug in n is 200, p is 0.47, 1 minus p is 1 minus 0.47. And you just see if that's high enough. What does that come out to? $49.82, right? Yeah, so what that means, again, the whole point of doing that is that now we know that the sampling distribution of p hat is normal. Technically approximately normal. Good question. Hold on, let me finish writing this and then I'll address it. Yeah, exactly. So the 1 minus p is 1 minus 47 or 1 minus 0.47. That comes out to 0.53. You could write it as 1 minus 0.47 if you want to. I just didn't. Okay. Now describe the sampling distribution of p hat. Okay, what do we need to describe a sampling distribution or distribution? We need the shape, we need the center, and we need a measure of spread. Do we know the shape?
Well,
It's approximately normal. Yes. All normal distributions are symmetrical. Symmetric or symmetrical? I don't even know. Sampling distribution of p hat is approximately normal. Again, the whole idea of a sampling distribution of p hat is if I get another sample, what should I expect p hat to be? That's sort of the idea of a sampling distribution. Because again, it could have been different shapes. Maybe it could have been uniform. Maybe it could have had a funky like shape like this. But what we found is it's about normal. It's approximately normal. So it's not normal, it's just a little weird, but it's close to normal. Okay. Go ahead and find the mean and the standard deviation of that distribution. Sure.
Like right here.
X is like a number. So X is like frequency and P is like relative.
Oh, okay.
Yeah.
Like there's no decimal then.
Not an X. But in P there should be, because P relative frequencies are decimal.
Not to say that, put it out, because then teachers just knock the wrong way. You guys have any questions?
I was just gonna ask her.
Yeah, well, not this one, it's the sampling distribution cap. On. The bridge. Okay, so do we have formulas for these, the mean and standard deviation? Where can you find it? You can find it either on page 6 or, as Allegras said, on the formula card. So you kind of want to get used to using the formula card. The mean and standard deviation of not a binomial random variable. The mean and standard deviation. Oh, actually, hold on. Yeah, that's a cool. Oh, just get, yeah, n times p divided by n gets you p. And then if you square this and divide by n squared and then take the square root, then you get p times 1 minus p over n. Huh. Basically what we're finding is the relative frequency version of a binomial. I never even noticed that really. Anyways, the formulas, I'm sorry, I didn't even show you on the formula card. All right, the mean and standard deviation of the sampling distribution of p hat. So the mean is p, the standard deviation is that ugly thing. But you just compute it. So the mean is 47. The standard deviation is 0.0353, approximately. Let's do 6 decimal places. Here you do want to use 6 decimal places since we're working mostly with small numbers anyways. You want to be extra precise. So it's going to be n times, what was the formula again? P times 1 minus p over n. Which is about 0.47 times 1 minus 0.47 divided by 200, but take the square root of that entire thing. I know some of you guys are copying, but let me just throw it into StatCrunch or into Desmos. Desmos. Was it over 200? Okay, it's about 0.035292. 0.035292.
Does that turn into a negative? Is it like 1?
It won't be a negative, no.
So why is there the tax?
Well, the 1 minus p? Are you talking about?
So then is it 1 times p or 1 minus?
1 minus p.
Okay.
Okay. Ready?
Get that answer to this one. No, this one.
All right, let's put it all together. The whole point of that is that when I get a new sample of 200 people, if I want to know the probability that the sample proportion, something related to the probability or the likelihood of getting a certain sample proportion, I actually know how to get it now. Because I can actually approximate with normal distribution with this mean and this standard deviation. So part B, in the sample obtained in part A of 200 people, what is the probability the proportion of Americans who can order a meal in a foreign language is less than 0.4? So in other words, I want the probability that the sample proportion is less than 0.4. And because I'm using, because I'm going to be estimating or approximating with the normal distribution, p hat is approximately normal, I can get away with doing less than or equal to. Okay, so again, that's the probability we want to find. If I get a new sample, what's the chance more than 40% of the sample can order a meal in a foreign language? All right, what was the mean of the distribution of p hat?
There.
Yeah. So if I drew out the distribution, here's 0.47, and I want the probability of more than 0.4. That more than 40% of my sample can order a meal in a second language. Oh, wait, how do I know? This is also kind of important to point out. I can get away with drawing a normal curve because I found out it's approximately normal. If I didn't find out it was approximately normal, if n times p times 1 minus p was not greater than or equal to 10, I couldn't do this because I wouldn't know what the shape is. But I know it's approximately normal. All right, how do you think we're going to get that area? Yeah, what type of distribution do we have? Yeah. All right, so we have a normal distribution, so we're going to use stat calc normal. Do we know the mean of this distribution of p hat? What is it? Yes. So if I looked at all samples of 200 of size 200, the average would be 47% who speak a second, who can order a meal in a foreign language. So the mean is 0.47. The standard deviation is, we'll just put it as 0.35292. And I want the probability that p hat is greater than or equal to, or sorry, is less than or equal to 0.4. And so if I get a new sample, what's the chance that I get this result? The chance I get this result is approximately 0.0237. Sure.
Can I see the bell? Shouldn't it be the other one?
Yes, huh? I drew it the incorrect way, right? No one told me. I was like, why is everyone going silent all of a sudden? It makes more sense now.
So then in that case, is the number that was unknown the area?
Yes, because it's the probability. Yeah, probabilities are the same thing as area. Yeah, and this is kind of a little bit weird where now the proportions are living as area and also on the number line.
Yeah.
So this is where it gets a little bit sort of annoying. Please, it's distracting. Okay, I have a question for you guys. Is Canvas up yet?
No.
No? All right.
Oh, no.
No, it's not a.
Yeah, I can't do words.
Okay, wait, now you guys are making me suspicious. I was trying to get you guys out of here as soon as possible. All right, so I'll send an email out. Please check your student emails because that's gonna be the only way I can really reach you guys for a bit, and everything is still a little bit tentative. So the exam we will push to Monday. The homework is also gonna be due Monday. If you do need, unfortunately, this is the one thing, is if you do need extra time, I will not be able to stay next Monday. Because, wait, oh no, I can stay on Monday. Yeah, never mind. Yeah, if you have extra time, I can stay on Monday, actually. Yeah. Okay, so the exam's gonna be on Monday. I'll try to figure out what's happening with Canvas, how to get you guys the homework stuff. If it's down for even longer, we can push it back if necessary, but I don't think that's gonna be the case. I do have office hours right now. You guys can not do the homework because you guys don't have it. Yes. Yeah, so if you need to get in contact with me, that's a good question. Email me Lopez _ Jesus at smc.edu. That's my email. If you guys need to get into contact with me, if I need to, it depends. If you email me at like 2:30 in the night, probably in 2 minutes. If you email me- No, it really depends. I'll try to get back to you guys as soon as possible. Yeah, so the one thing, please keep an eye on your emails for now. All right, get out of here. Sorry.